Hello, I Dr. Vijay Chandra Jadala welcomes you to VC Tech Education. Today we are going to discuss the theoretical concepts of Internet of Things, sensing and actuating devices. This is IoT series 008. Till now, that is IoT series 001 to IoT 007, the practical concepts were explained. If this is a starting video for you, please refer IoT 1 to 7 practical sessions. Today we are going to discuss regarding the theoretical concepts of Internet of Things, that is what do you mean by a sensor, what is an actuator, what is a transducer, and what are the other things in IoT, that is MEMS, Micro-electromechanical systems, and regarding feedback control system, as well as feed front control system. Today's agenda: Internet of Things, role of sensors and actuators, regarding transducers. A transducer is a device which converts one form of energy into the another form. Next, regarding sensors, a sensor is a device that detects and responds to some type of input from the physical environment. The specific input could be light, heat, motion, moisture, pressure, and any one of the environmental phenomena. Next comes to the actuators. An actuator is a device that produces a motion by converting energy and the signals going into the system. The motion it produces can be either rotary or linear. Next comes to the MEMS, Micro-electromechanical systems. MEMS is a process technology used to create tiny integrated devices or systems that combine mechanical and electrical components. Feedback control system. A feedback control system is a system whose output is controlled using its measurement as a feedback signal. This feedback control signal is compared with the reference signal to generate an error signal, which is filtered by the controller to produce the system control input. Now regarding transducer. A transducer is any device which converts one form of energy into another. Examples of transducers are as follows. A microphone converts sound into electrical pulses, and a loudspeaker converts electrical pulses into sound. Sound energy to electrical energy and vice versa. A solar cell converts light into electricity, and thermocouple converts thermal electricity energy into electrical energy. The light bulb, the electric bulb, produces light by passing current into a filament. Thus, a light bulb is a transducer for converting electrical energy into optical energy. An electrical motor is a transducer for conversion of electricity into mechanical energy or motion. Transducer converts one type of energy into another. Here, as an example shown, a simple input-output system using sound transducers. Here, microphone is an input device, loudspeaker is an output device, amplifier is a controller. So, input-output between processing unit. The processing or controlling unit is an amplifier. which collects the input signals through microphone and amplifies it and gives an output through loudspeaker. There are two kinds of transducers, one is sensor and another is the actuator. Role of sensors and actuators. Sensors sense unknown signals and parameters from its environment. Actuators perform some physical actions based on control signal. Sensor: vision and imaging sensor, temperature sensor, radiation sensor, proximity sensor, pressure sensor, position sensor, photoelectric sensor, practical sensor, motion sensor, metal sensor, level sensor, leak sensor, humidity sensor, gas and chemical sensors, force sensor, flow sensor, flaw sensor, flame sensor, electrical sensors and contact sensors. Among 20 different sensors are discussed here and shown on screen, where each sensor has its own capabilities. Generally, they are used in electrical, mechanical, agricultural and healthcare industries. These sensors are used for the demonstration purpose as part of practicals. Already 7 series of practicals are given along with this video at VC Tech Education in playlist of IoT, Internet of Things. So whoever visiting VC Tech Education, please subscribe, and if you like the video, please like it. And the next thing is here the different sensors which are used for the practical sessions are around 7, where soil moisture sensor is used, humidity sensor is used, and gas sensors are used. So these sensors already experiments are done as a series. Please go through it, and remaining sensors in future I am going to do the practical sessions. Next comes to the common sensor categories and sensors applications for smarter world. There is only 7% for ultrasounds or radio. Magnetic sensors are 18%. Electrical sensors are of 4%. Leaks and levels controlling sensors are 2%. Force load pressure sensors are 6%. Temperature related sensors are 11%. Motion velocity displacement related sensors are 3%. Humidity, moisture or water related sensors are of 12%. Flow sensors are of 3%. Sound sensors are of 1%. Chemical or gas related sensors are of 12%. Proximity sensors are of 3%. Vibration are 4%. And acceleration tilt is of 9%. So these are the different sensors which are of related to the Internet of Things in smart living. Next comes to the block diagram of sensor building blocks, smart sensor building blocks, that is how the sensors units are used. The block diagram clearly explains how the sensors are used. Sensing unit, from the sensing unit the signal will be taken place by the signal controlling. From there analog to digital conversions will be done, whereas the bidirectional communication will be done along the local user interface, application algorithms and memory. The data will be continuously on stored through memory, where communication unit is the bidirectional or the receiver to take the output. So this is the overall structure of the smart sensing building blocks, that is sensing block diagram. Next comes to the architecture, how they are used, and in combination of architecture and sensor with a central control system, we taken an example. temperature of the that is fire accidents. Let's take an example of a fire accident. Automatic detection of fire and sprinkling of water on fire is the target project here, where the temperature will be identified based on the heat through the sensor. Signal sends to detect the signal to the control center. Once the control center confirms it as a heat related concept, then control center sends command to sprinkler. Then the actuator start working and it makes sure that the sprinkler turns on and puts off the flame. This is a simple example how in combination of sensors and actuators the real-time examples can be solved. Real-time problems can be solved. Next comes to the different actuators. In generally these all actuators are used in mechanical stream, whereas DC motor, DC gear motor, RC servo motor, stepper motor, BLDC motor, smart servo motors, harmonic devices, linear electric actuators. So as a session of the practicals, we are going to do IoT devices on stepper motor and DC motor and even servo motor in later sections. Role of sensor and actuators. We will take another example related to the role of sensor and actuators, which helps in agricultural industry. Soil moisture will be detected through the water content. So sensor is used here to detect the soil moisture. Sensor that detects the water level in the soil, and based on the Wi-Fi sends direct value signal to the control center, and the control center sends command to the water pump, and actuator is switched off or switched on based on the signals received. This is the example or the experiment real-time example which helps the farmers in agriculture industry. Next comes to the electromechanical systems. Here ultra-wide angle thermal MEMS sensor, ultra-wide angle thermal MEMS sensor related concepts we are going to see here. Micro-electromechanical systems are related to the microelectromechatronics and microsystems, which constitutes the technology of microscopic devices, particularly those with moving parts. Some examples of current MEMS devices include accelerators for airbag sensors, inkjet printers heads, projection display chips, blood pressure sensors, optical switches, microvalves, biosensors. The different types of MEMS generally are MEMS accelerometers, MEMS gyroscopes, MEMS pressure sensors, MEMS magnetic field sensors. So these micro-electromechanical devices are different devices which are a part of Internet of Things. Next comes to the final concept and the actual concept, where we are going to club the actuators, sensors and MEMS, that is a feedback control system. A feedback control system is a system whose output is controlled using its measurement as a feedback signal. This feedback signal is compared with a reference signal to generate an error signal, which is filtered by a controller to produce a system control unit. Here we can see on screen sensors and actuators which are used in feedback control system. where the input commands will be used by the user interface, where digital computer or the system is used. Signals conditioning and amplification is the next step, where the process will be done through actuators and sensors. If they get the response, the output will be given, or it will be returned back to the signal conditioning filtering, and again the recycle will be taken place. These sensors and actuators are interdependable related to the control system. A control system is a system which is of dynamic system that contains a controller as an integral part. The purpose of the control system is to generate control signals that will drive the process that is being controlled, called the plant. The sensors and actuators in feedback control system. Sensors and actuators are dispensable in the control system. A control system is a dynamic system that contains a controller as an integral part. The purpose of the control is to generate control signals which will drive the process that is being controlled, that is the plant, is a desired manner, that is according to some performance specifications using various control devices. Especially in feedback control system, the control signals are generated based on the sensed response signal of the plant. Sensors, actuators and other main components in feedback control system are systematically shown. So here the different terms which are used here in the feedback control system are listed down. That is plant or process, where the system to be controlled, inputs, commands, driving signals and extractions known and unknown comes under input, whereas output, the response which it is given to by the system, is the output. Next, sensors, devices that measure system variable, exceptions, responses, etc. Actuators, devices that derive various parts of the system. Next comes to the controller, device that generate control system. Next, control law, relation or a scheme according to which the control signals is generated. Control system, at least the plant and the controller may be, which include sensors, signal conditioning and other component as well, comes under the control system. Feedback control, control is determined according to the plant response. Open loop control, plant response is not used to determine the control system. Control signal is determined according to plant activation or a model of the plant. Here in this diagram it is clearly shown regarding the feedback control signals. Several discrete blocks are shown here, where depending on various functions that takes place typical control systems. In the practical control system, this type of clear demonstration of the components might be difficult. Here the reference model or reference command is given to the controller, where based on the power, where digital to analog signal conversion will be taken place through control signal. The power will used for the signal conditioning, and then it comes to the actuator, where drive extraction and response will be calculated, operated by plant process, where this area comes under the distribution then this will be connected to the sensors or transducers, where the conditional signaling will be based on the conditional signaling, the feedback will be calculated. Sensors, actuators in the feedback control system. The following performance will be considered on the requirement as of important. The parameters which we are going to discuss regarding performance requirement are significantly stable response, that is stability. Specifically, the response of the system to an initial condition extraction can be decay based on the steady state. The response will be bounded into the bounded input bounded output BIBO stability. Next, sufficiently fast response, speed of response or bandwidth. The system should react quickly to a control input or extraction. Then low sensitivity to noise, external disturbances, model errors and parameter variations, sensitivity and robustness. High sensitivity to control inputs, that is input sensitivity. Next, lower rate, for example tracking error and steady state error, that is accuracy. Next is a reduced coupling among system variables, that is core sensitivity or dynamic coupling. Next comes to the performance specifications of a control system. Here there are attributes, then desired values, objective and specification. So the stability level will be the high based. The objective is to response to that does not grow without limit or decays to the desired value. The specifications overshoot settling time, pole, that is eigenvalue locations, time constraints, phase and grain margins, damping ratios. Next comes to speed of the response, steady state error, robustness and dynamic interaction. These all considered as the performance specification of a control system. So the cross sensitivity, cross transfer functions are the specifications among them, and even the error tolerance is also calculated, and noise tolerance, disturbance, error tolerance measurement, model error tolerance, all will be calculated as part of the specifications to improve the performance of a control system. Feedback and feed forward control system. As we all know about the feedback, it is also known as closed loop control system, whereas open loop is the feed forward. If a plant is stable and it is completely and accurately known, and if the inputs of the plant can be precisely generated by the controller and applied, then accurate control might be possible even without feedback control. Under these circumstances, a measurement system is not needed, or at least not needed for feedback, and thus we have an open loop control system. In open loop control system, we do not use current information on system response to determine the control signals. In other words, there is no feedback, even though the sensor is not explicitly needed in an open loop architecture. Sensor may be employed within open loop system to monitor the applied input, the resulting response and possible disturbance units. So this is all about the feedback and forward control. Next, even if a feedback control system, there may be inputs that are not sensed and used in feedback control. Some of these inputs might be important variables for the plant, but more commonly they are undesirable inputs such as external disturbances, which are unwanted yet unavoidable. Generally, the performance of the control system can be improved by measuring these unknown inputs and somehow using the information to generate control signals. In feedback control, unknown inputs are measured and the input along with desired inputs is used to generate control signals that can reduce errors due to these unknown input or variations in them. The reason for calling this method feed-forward control system from the fact that the associated measurement and control both expansion both take place in forward path of the control system. So this is the overall diagram for the control system where thermostat, temperature control, transmitter is used, value actuator is used, plot flame detector is used, then main flame detector, in the furnace the water content, burner chamber, and all the plant design is shown here where water flow rate, temperature, cold water into furnace, temperature outside the room will be calculated based on the sensors and actuators. So feedback and feed forward control where temperature is set as an input, where controller, furnace, the main inputs which are shown here that are water flow rate, temperature of cold water into the furnace and temperature of outside room will be calculated as the unknown inputs for the furnace, and the room temperature output, and sensors and transducers are used to control or identify the temperature in the furnace or industry area. Importance of estimation in sensing. The sensor measurement might provide the true value of required parameter or variable that is needed for two main reasons. Number one, measured value may not be required quantity and has the computed for the measured value or values used a stable suitable model. The sensor or even the sensing process is not perfect and will introduce measurement error. So here we are going to get the measurements, measurement values, and the measurement errors. Hence, sensing is viewed as a problem of estimation where the value of the measured quantity is estimated using the measured data. The main two categories of error, model error and measurement error, enters into the process of the estimation and will affect the accuracy of the result. The model of the error arises known input distributions and also treated as model error. However, the quantity of the interest related to the quantity that is measured will be calculated. So sensing, estimation sensing is the major part done by the sensors in Internet of Things, which are supported by the actuators. And here in this session we discussed about what is a sensor, what is an actuator, what is the role of MEMS, that is micro mechanical system, what do you mean by feedback control system, how these transducers, sensors, actuators, MEMS are used in the real life examples, that is the factory where the furnace the temperature control is done based on these IoT devices and the feedback control system, whereas we even seen the feed forward control system, that is the open control system. Hope you are understood well. the concepts. Thank you. Thanks a lot. Please like, comment, share and subscribe. Thanks for watching.